Hello, this is Alex from Mosaic Work Studios, and today I will continue the discussion I started in my last video. If you haven't seen that video, a short description is that I talked about how software engineering is really about applying a new science, a science that is not fully complete, a science of knowledge. And that this is at the core of how we develop software, and that as software engineers, as software developers, we should also look at how to manage knowledge, basically. And to make this clearer, in the meantime, I realized that I can use a metaphor, and the metaphor would be that any software development team is actually a knowledge refinery. So if you think about it, what we do is we start from very vague wants and needs, very vague requirements. To tell you an anecdote, one of the requirements that some of my colleagues received in the past was, I want this button to be more sexy. You know, what does this mean? How is this actionable? They had absolutely no idea. They had to go through some more discussions to figure out, what exactly does that mean? What does that mean in terms of color, in terms of, shapes and things like this. So we start from very vague wants and needs and requirements, and we end with something that's very precise. We end with code. Code has to be very precise because computers cannot use ambiguity, at least not when we are programming them. Therefore, if you look at this from the point of view of a system, what you have is an input of very vague requirements, an output of very precise code, and in between you have this thing which I'm calling a knowledge refinery, because basically what it does is it's taking crude knowledge, refining it until it becomes very, very precise, and it's stored in code. So managing this knowledge is fundamental to the success of software development projects. And I've noticed in many situations in the past when knowledge was lost during the lifetime of a project. So for example, a team has started developing a project, but then people left. And then the people who continued working on the project in the team, they had less and less idea about, about the project itself, about how the code is structured, about what is implemented, and all these things. And this is one of the most difficult problems in management of software teams. So when you notice that your teams don't have the necessary knowledge anymore, it's very, very difficult to raise them back, to bring the knowledge back into the team. Therefore, what we need to do is to keep this knowledge at a very high level during the lifetime of a project. But in this video, what I like to do is to focus more on how to manage knowledge, and basically on a few ideas about the knowledge, what the properties of knowledge are, kind of what the laws that are governing knowledge are. And I have to say that all these things are empirical. Some of them have a basis in neuroscience, but most of them are empirical. I have noticed them many, many times working with teams. So what you do with empirical knowledge is you can take this, try to apply it in your projects, experiment, see whether you get the same results or whether you get different results. So first of all, let's think a bit about knowledge. What we want is to, if you think about knowledge is in an abstract way, we want to do basically two things with it. The reason for managing knowledge is that most of the times we are working on complex projects. which means that we need to involve more people in those projects. And when we have more people involved, what we need to do is two things. One of them is to store knowledge. The second is to transfer knowledge from person to person. Because often we have no idea, one person doesn't have any idea of how to solve a complex problem, so you need a collaboration between more people. There are more systems involved, there are more elements involved in the project itself, in the requirement. So how do we store knowledge? Well, the first way of storing knowledge is the brain, right? This is where knowledge resides often. And if we store knowledge in the brain, this is great, we can do this. But we also know from neuroscience that something is happening with the knowledge. Memory is not a perfect way of recording things. Instead, what happens is that knowledge decays over time. So things that I've learned, let's say 1 week, 2 weeks, 1 month, 2 months ago, I will probably forget. The details will go away. I will only remember those things that I keep reusing often. This is how human memory works. So what this means is that what I'm getting is, in time, I'm getting a knowledge loss, right? I'm losing knowledge. The second problem, the second way of storing knowledge is documents. We can write text, we can draw diagrams, we can have these, for example, requirement documents, architecture documents, all kinds of documentation like this. These are very good, but the problem with them is that it's hard to write a document that's very precise. And the second problem is that they tend to be left behind. So you need to keep updating those. You need to keep them up to date because knowledge evolves in time, right? So when you are developing a software project or a product, what you do is you learn more and more about stuff, about what you're doing, about various things that are involved in your products, about your users, about their needs, about the features, about maybe different APIs that you can connect with and things like this. So you learn more and more about your product, and you need to keep your documents up to date. And because these documents it's hard to keep them precise, once again the knowledge tends to get lost in time. And the documents tend to be left behind while the knowledge advances. A third way of storing knowledge is video or audio recordings. So we can, like I'm doing now, I can talk into a camera or make a presentation, and we can store this somewhere. The problem with this is that this stores a specific moment in time. It's a very good recording of what I'm talking about. It captures much more about the knowledge, but it doesn't, it's contextual and it's limited to a specific time frame. So once again, as time evolves, the things that I'm talking about here will probably become less and less important, right? So the knowledge tends to go up while these stay on the same level. And the fourth way of storing knowledge is, of course, writing code. And writing code has a lot, so it has one big disadvantage. It's harder than the other ones because it's less flexible. So if I'm storing stuff in the brain, I can be more flexible. If I have documents, I can write phrases, comments. It's a free format. If I'm writing code, it has to work. And because it has to work, it has to be very precise. and because it has to be very precise, it tends to be quite limited in flexibility. So the issue here is that, okay, we can store things in code, and but it's less flexible compared to other things. However, it's much more precise. So if you want to get the most precise way of storing knowledge, it's actually in the code. And often when I go to talk to teams and I consult various teams, they start by talking to me about the various documents, and they show me diagrams, and they talk to me about what they do and how they do things and about the features and so on. But really what I want to see is the code, because the whole knowledge is gathered there. So I have one mantra that says, in code we trust. At a certain point in time, the only thing that's capturing precisely what's in a software product is the code. So these are 4 different ways of storing knowledge. How about transferring knowledge? As you can, it's fairly simple. If I'm storing knowledge in my brain, the only way to, I can write a document, or I can talk to other people, or I can record stuff, right? So it connects with the storage. But the interesting part is when I'm talking to somebody else. So let's say I'm storing some knowledge in my head, I want to transfer it to someone else. I'm talking about it, maybe I'm drawing stuff, I'm presenting and so on. What happens then? Well, the problem is that this type of communication is lossy, right? So whenever we transfer knowledge from one brain to another, this is a lossy communication. And you can test this easily by playing the telephone game. Basically what the telephone game is showing us is that knowledge gets lost as we move forward. So the longer the chain, the more knowledge we lose. And let's say, on the other hand, maybe I'm writing a document, right? And we are having the same problem. This means that I'm storing the knowledge that I have now. And once again, it's a lossy type of communication, a lossy type of transfer, because maybe I will forget to write some things. It's not necessary that I will cover everything. And if you look at how good specifications and very precise specifications are written, they are actually very close to code, right? Because code is the most precise way of storing knowledge. So these are some interesting things. Okay, so what have we learned? We learned a few things. First, knowledge decays. So it's a natural thing. Whenever we keep knowledge in our heads, it tends to decay. When we store knowledge in a static way, our knowledge also evolves in time. So we tend to forget things, but we tend to also learn other things about what we are doing. And also what we've learned is that the most precise way to store knowledge is the code. So this leads us to some very interesting ideas, right? What does this mean in practice for a software development project? Well, it means that we should favor practices that have a few characteristics. We want practices that amplify knowledge. We want practices that allow us to store the knowledge we gather in code. We want practices that allow us to retrieve the knowledge from code. We want practices that allow us to update the code easily and quickly when knowledge evolves, right? Because knowledge evolves, but the code tends to stay. It has the same problem as documents. It tends to remain at a certain level. We learn more and more. This knowledge should be reintegrated in the code. So what are some examples of practices that fit these ideas? Well, first one is in the category of amplifying knowledge. What does it mean to amplify knowledge? Well, basically when you are working with knowledge, what you need is more brain power, right? How do you get more brain power? Well, you have more collaboration. So you want more collaboration between brains, but collaboration in a way that's effective. So a few examples of collaboration can be pair programming or pairing on various things. You can do pair testing, you can do reviews, you can do all kinds of things like this that allow you to amplify knowledge. Or mob programming, right? Mob programming is this practice where the whole development team is looking at one single screen or projector, and only one person is typing, but the people who are driving the development is actually the people who are watching, not the person who is at the keyboard. So in this case, you have a lot of brains thinking and a pair of hands typing. And that's basically the idea. So you amplify knowledge, but putting all these people together, right? All these brain power together. And this is why mob programming has some advantages, right? Another thing, so about storing knowledge in code. How do we store knowledge in code? Well, what can we store? We can store specifications in the form of executable specifications. We can store tests in the form of automated tests. And of course, we can store basically knowledge about how the system works in the form of automated tests of code and things like this, right? But now this is not enough. What we need is not only to store knowledge in code, which we do anyway. What we need is also to be able to retrieve the knowledge from code. So when you go into a project, when you look into a code base, you should be able to immediately retrieve some of the knowledge about about what that code is doing, why it's doing things in a certain way, and so on. And what we need there is, for example, screaming architecture. So structuring your packages or your modules or your namespaces such as when you see their names, you understand what the product is doing rather than what the technical components are. And this allows you to retrieve knowledge about the business itself. Another thing which is lower level, another practice, is clean code. Why do we want to do clean code? Well, basically because when you have your code structured in a certain way, you can then read it, understand it quickly, so you can retrieve the knowledge from the code much faster. What about updating the knowledge, updating the code to reflect new knowledge? Well, this is the practice of refactoring. And in fact, the initial metaphor for technical debt, as Ward Cunningham has defined it, is that technical debt is basically when you structure your code in a certain way, but the knowledge evolves, and then you are left behind. So basically what you need to do is to pay this technical debt through refactoring, such that you bring the code structure back to reflecting the current knowledge that you have. So you need merciless refactoring to allow you to maintain the current knowledge in the code in a way that's easy to retrieve. And of course, to bind more of these things together, we have test-driven development, which also has other benefits, but one of the benefits is that it stores some part of specification, and it allows you to write and to structure your code in such a way that reflects your current knowledge. Test-driven development is quite interesting because it also allows you to to get to various points where you have questions and solve those questions at the right moment. So basically you can introduce knowledge in code at the right time. Right, so this is a quick description of my thoughts on how to store, how to retrieve knowledge, and why knowledge is in the core of software engineering. I believe this to be a very important area. I have seen many situations where if we just do a small thing, just change one small thing in the team in order to amplify knowledge or to store knowledge better, then already the projects are going much better, much faster. So I have seen from my empirical experiments that these ideas work, but of course you need to try them for yourself. And I think that the big idea behind all this is that if we put knowledge in the center of software development, we finally understand why certain practices work. These practices like pair programming or test-driven development, which make no sense if you think about software like construction, like a construction metaphor. They work if you think about the code as knowledge and storing knowledge and retrieving knowledge. Suddenly everything kind of connects together. So I really like these ideas, but let me know what you think. And as you know, I have a book published on Amazon. It's called Functional Programming in C++. And I'm currently working on a new book called Mastering Software Engineering in C++. I hope you'll check these out. And if you have any questions, any comments, please let me know. Bye.